I've spent 2 months studying section 3. Actually, it wasn't exactly full time because 4 of the weeks, or maybe 5, I fought a lung infection, and the immune system commandeered so many resources that I could think for no more than a half to 1 hour per day. Really analytic thinking, and I am also doing other things than mathematics. But I really had to work very much, and that's because when we came to computing this, I found the book to be a terrible mess, unsystematic, with a lot of ad hoc tricks that we needed to do. Therefore, I thought what we need is really to work systematically on the Gauss sums. So that's what I did, and so I had to develop it myself. I couldn't find anything on the net, so that's what I did. First we define the simple Gauss sum, and then the theorem in the book, which I can't prove, by the way. I haven't found a way to prove that. And then we generalize with an L put up here, which is actually the sum we need in the book. That's then Sn of minus L, but I couldn't see any reason to introduce a negative sign here and commit a lot of sign errors during the derivations. We can take L out if they are L and N are co-prime. That's also explained in the book. And in more general, we can take L out from the generalized sum here, provided, of course, that N and L are co-prime. And then if M and N are co-prime, then we can parameterize the summation variable by H and K in these rings. And that's a trick I actually learned while reading the book. If we map J modulo M, point J modulo M, then by the Chinese remainder theorem, it's 1-to-1, and I know the inverse mapping, so I would have used that, which is more complicated. This is quite simple. And they have done this in the book, and this, of course, is where we can use the reciprocal theorem, and that was the way that Gauss himself proved one of his proofs, many proofs of the reciprocity theorem of the Legendre symbols. In conjunction with this formula. So applying that leads to this guy, which we shall use many times. Using this factorization, computing the Gauss sums are reduced to the prime powers. And we parameterize AP plus B, where B is the remainder by division with P, and A the quotient. This trick is also used in the book. All the tricks are used in the book, by the way, but here they come in a systematic way, so we only need to do each trick once, and then we get a formula we can use later. I believe what I'm doing here is making the section, or the last third of the section, much easier to read. Now we split it up, and this is what we get. I won't show you every detail that's done, because you can always pause the video and think it through yourself. L here, it may divide, P may divide it, but unless it actually cancels, then the first sum vanishes. I said that wrong. If L divided by P minus first doesn't gives an integer, then it vanishes. Otherwise, is that clear? Yeah, because then it's a non-trivial root of unity, right? So we must assume that L can be written as some lambda times P to nu minus 1. Let's just call it n minus 1. Oh, yeah. It's because they use nu in the book as prime powers. So that was the first result. Then we must compute what this gives, and we can do that explicitly. And it turns out that if V is even, then this is unity. So if this is unity, then we get P minus 1. And if this is unity and this is not, then we get 0, because the sum of the values of the index gives naught. And then in the special case, we actually can reduce it to, well, never mind. You can do the details yourself. It's not difficult. And then we multiply by P to nu minus first, and then we end up with this result. And we assume nu being greater than or equal to 2, but this formula also holds when nu is unity. In the book, we keep L fixed and vary n, so we need to check what is the value of this for fixed nu, varying h, and I've collected the results here. Now we have an easy proof of the lemma in the book. We separate using the first theorem here, where we have nu I is larger than or equal to 1. In case Pi fails to divide L, then this vanishes. Oh, that's what I write here. Then we have this result from up here. This is this result. And that leads immediately to, without the use of any delta functions. So I think that's more easy than they do it in the book, because we have done all the manipulations with the indices, so we can just make simple algebra on the Gauss sums. Now we can do the computations in the third quarter of the section. And this, of course, is quite easy with 2 a power of 4. And then we go to the odd primes. First, when L naught contains the prime, And it's just going through the algebra, and the only difficult point comes when we sum over the powers of, we get a simplification. We are summing over n naught, which is not divisible by p, and then multiplied by p to h, where h then goes from naught to infinity. So we don't need to distinguish between odd and even factors of h. So we get a major simplification here. So here we have n and l. Oh, that's, minus l. We get an odd one because p divides L naught once. And then it turns out that this one is only non-zero when h is even. Oh, it's better to look down here. We have an odd guy, and when h is naught, even between naught and 2 nu, so at odd values it vanishes. That is nice, because then h is even, nothing here. And of course, this is epsilon n naught. And this is unity, so it becomes very simple. And then we get the formula from the book. Nice and simple. The case where p fails to divide L naught is actually a little more complicated, but it's basically the same. We need this formula that is also explained in the book. I think it should be derived using this formula and not going through all 4 combinations of p and n modulo 4 as he writes in the book. So I like this better. And then we end up with this. And this last reduction actually took me 2 hours. So it's true it's elementary, but I think not it's trivial. And also at one point one needs this relation, because otherwise we had minus lambda up here. So yeah. All right. I would just show you this work because I thought that you might like to use it if you had to teach this material, or maybe teach the Gauss sums. I have put this document on my homepage, and you'll be able to download it by the link in the description. So a little report on the problems studying this section and why it took 2 months.